So here's our practice midterm. Our midterm is going to be almost identical to it, okay? Let's start by reviewing absolute value equations. And here's the first one. So when we solve an absolute value equation or inequality, the first step is to isolate the absolute value. You want to get this by itself on the left side of the equal sign. You don't want the 7, you don't want the -3. So we're going to get rid of that -3 first by doing the opposite, +3. Well, you do to one side, do the other side, +3. So we have the new equation, 7. You still have the absolute value of 2x minus 9, close absolute value, equals 7. Now this is really a 7 times this stuff. And do not distribute. That'd be incorrect. Do not distribute. You need to isolate the absolute value, which means you got to get rid of the multiplication of 7, which means you got to do the opposite, divided by 7. So when it cancels, you now have the absolute value of 2x minus 9 equaling 1. And now that's isolated, now you could jump to the positive and negative situations. You guys remember that? Okay. So the positive situation, you just write it exactly the way it is, 2x minus 9, without the absolute values. The negative situation, you again write it without the absolute values, 2x minus 9, but you flip the equal sign or the inequality. So you flip it and it still says equal, but then you also change the sign of the right side. So it's going to be a -1 over there. Now I know you're probably thinking, why do you say flip it and change the sign if you flip it and it still says equal? Because whenever you have an inequality, you're going to have to flip it. And if it is a greater than, you're going to flip it to a less than. If it's a less than, you're going to flip it to a greater than, right? So anyways, that's the process. Now you got to solve both of them. So you go +9, +9. You have 2x equaling 10. And you divide by 2, you have x equals 5. So that's one possible answer. The other one, you add 9, you're going to end up with 2x equaling 8. And then you divide by 2. So you have x equals 4. So those are your two answers, maybe, because you're supposed to technically plug them in and make sure that you don't have extraneous solutions. So when you do plug in the 5 right there, 2 times 5 is 10. 10 minus 9 is 1. And of course, 7 times 1 is 7. And 7 minus 3 really is 4. So that one works. We just checked it by plugging it in. And now we take the 4, plug it in right there. 2 times 4 is 8. 8 minus 9 is -1. The absolute value of -1 is +1. So 7 times +1 is 7. And 7 minus 3 again equals 4. So that one also works. That's what we call double checking. That's your answer for number 1. Any questions? Back to the worksheet. Number 2, it's another absolute value equation. Let's do that one. So once again, you want to first make sure that the absolute value is by itself. There is no times 2 out in the front that you have to divide by 2. There is no -7 at the end that you have to add 7. It's already isolated. Step 1's done for you. You can now jump to step 2, which is doing the positive situation and the negative situation. Squiggly line in between. Now, again, the positive situation is writing it exactly the way it is without the absolute values. So you have a 3x minus 1 equals, you have a 2x plus 26. Exactly the way it is without the absolute values. Now, the negative situation is same thing, no absolute value sticks, but you do have to flip the equal sign, which is still going to say equal, and you have to change the signs of the right side. Now, since you have two terms, you're going to have to change both of those signs. It's kind of like multiplying this whole right side by -1. So once again, it's still 3x minus 1, just like the positive situation. You just took off those absolute values. But on the right side, you have to change the sign. So that's going to become a -2x, and it's going to become a -26 instead of a +26. And then you solve both of them, get your two answers, and of course, test them. Let's do that. Let's solve the first one. You have x's on both sides of the equal sign. You don't want that, so let's get rid of the 2x by subtracting 2x. What you do to one side, do to the other. You're going to end up with 1x minus 1 equals 26. And all you got to do is get rid of that -1 by adding 1. Adding 1, you'll end up with x equaling 27. That's a possible answer. I'm not going to say that for sure it is because I still need to plug it in to see if it works. Let's do the negative situation before we plug in anything or check anything. The negative situation, again, you don't want x's on both sides of the equal sign, so I want to get rid of the minus 2x by doing the opposite, plus 2x. What you do to one side, do to the other, plus 2x. You're going to end up with 5x minus 1 equals negative 26. And now you want to get x by itself, so that means you're going to get rid of the minus 1 first by doing a plus 1 and a plus 1. Your new equation is 5x is left over on the left side. Negative 25 is what's on the right side. You're going to get rid of that multiplication of 5 by dividing by 5 and dividing by 5, getting your final answer x equals negative 5. Maybe, because we need to double check it. So if you take 27 and plug it in right there, so with the calculator, that's 81. Take away 1 is 80. So the absolute value of 80 is 80. So I'm just going to put an 80 on this side, just, so I can keep track of the math that I just did. And if I plug in a 27 over here, with the calculator, 2 times 27, that's 54. And 54 plus 26 with the calculator is also 80. So for sure, I'm absolutely positive that 27 is a solution. That's a correct answer, okay? Now then you test the other one, negative 5, put that in with the calculator, that'd be a negative 15. Negative 15 minus 1 is negative 16. The absolute value of negative 16 is a positive 16. Okay, so 16 is what we have now on the left side. And if we plug in that negative 5 right there, 2 times negative 5 is negative 10, and negative 10 plus 26 is also positive 16, right? So it does work. So both of these answers are correct, so you have to show both of them to get full credit. Let's go back to the worksheet. So the next part of the worksheet, it might be a good idea to jump to number 5, since number 5 is an absolute value inequality. We have all inequalities, but since we just got done with absolute value equations, we might as well jump to number 5, go out of order a little, and solve this absolute value inequality, okay? So let's do that. Let's get this number 5 and do it over here. So you want to isolate the absolute value first, okay? So what do we need to do to isolate the absolute value? Get rid of the minus 18 by doing plus 18. Cancels out, plus 18. Your new absolute value inequality is going to be the absolute value of 3x plus 3, close absolute value, is less than or equal to 12, correct? So there's your absolute value inequality. Now, let's pretend that when I did this math, this would have been a negative 12, right? Then that's easy, because if this would have been a negative 12, you could stop right there and say no solution. Now, why is that? Because the absolute value of anything has to be positive. So if this were a negative 12, it would be impossible for the absolute value of something to be less than negative 12. That would imply that it's negative. So if it were a negative 12, you could stop right there and say no solution. But it's not. It's a positive 12, so we must keep going. So we're going to do the positive situation and the negative situation. The positive situation is writing it exactly the way it is without the inequality, the absolute value sticks, the symbols. Can't even speak right now. The negative situation is the same thing, 3x plus 3, but we flip the inequality, change the inequality, and also slap a negative on that 12. And now we're going to solve both. So on the positive situation, I subtract 3. We're going to have 3x is less than or equal to 9, which is really saying 3 times x is less than or equal to 9. So you're going to divide by 3, and you're going to end up with x is less than or equal to 3. By the way, if I were dividing by a negative, I'd have to flip that inequality symbol, but I didn't. So this is a possible answer, okay? Let's jump to the negative situation. Again, I am going to subtract 3. That'll cancel out. I have a 3x is greater than or equal to negative 15. Final step is to divide by 3. X is, you don't flip it, you keep it. X is greater than or equal to negative 5. Okay. Now, the thing with inequalities is that you're talking about an area of answers. So we actually have to go to a number line and see where the solutions are at. And when you're on a number line, I recommend putting the smaller number, -5, on the left side, the bigger number, +3, on the right side, and then graphing the inequalities. So this one says x is less than or equal to 3. So that'd be a solid dot at 3, less than is to the left, okay? And this other one says x is greater than or equal to -5. Greater than or equal to means a solid dot at -5, greater than is to the right. So the area is together, okay? So if the area is together, you're gonna have to write this as a compound inequality written together, okay? And it always, since you already have it in a number line where the smaller number's on the left and the bigger number's on the right, all you gotta do is put an x right in there in between them and put less than symbols. Once again, smaller number on the left, bigger number on the right, x in the middle, and you're gonna have both of these being less than symbols, and of course, or equal to because they were solid dots, or because we had the solid line underneath the original one. But this is your answer on this question. Any questions on that? No? I might as well take this opportunity to talk. What if you were to get your two answers and you graph them and they're not together, if they're apart? Okay, so like let's pretend you did the work and you got x is less than or equal to -3, let's say, and also x is greater than or equal to +5, okay? So let's pretend that we had that. Then if you graph this guy, you put your smaller number, -3, on the left side, the bigger number, +5, on the right side. And this first one reads x is less than or equal to, that's to the left. This one reads x is greater than or equal to the right. These areas are apart. So if the areas are apart, you're gonna write your inequality not together like this. You're gonna actually keep them apart with the word or. So you would say x is less than or equal to -3, or x is greater than or equal to +5. So you just keep them apart with the word or. Very important stuff here, guys. I hope you remember. If it's together, you're gonna write it together with the x in the middle as a compound inequality. If the areas are apart, you're gonna keep those answers apart with the word or between them. Sounds good? So we just did this one. Let's go back and do a regular inequality and solving a compound inequality. A regular inequality is Algebra 1 stuff. Everybody should be able to ace that. Of course, you're gonna simplify first. You're gonna say -6 times 2x, that's -12x. -6 times -1, that's a +6. And of course, you're gonna bring down the less than and the 27. So you wanna get x by itself on the left side. You're gonna subtract 6. You're gonna end up with a -12x is less than 21. Now that really says -12 times x. So you don't want that multiplication of a -12. So you're gonna divide by -12 and divide by -12, okay? Now that will cancel out and you'll now have the nice beautiful x. And since you divided by a negative on your last step, you have to flip that inequality symbol. That's the only difference between solving an equation and an inequality. When you're solving an inequality, if on your last step you multiply or divide by a negative, you have to flip the inequality symbol. So that less than became a greater than now. 21 divided by -12, unfortunately, I can't do that, right? So it's gonna stay a fraction. You could leave it as a reduced improper fraction. What do I mean by that? You have a 21 up here and a 12 down here. They're both divisible by 3. So you could actually reduce, or the calculator will do it for you, and you'll get a 7/4. And of course, this whole thing's negative because a positive divided by a negative is a negative. So your answer would be x is greater than -7/4. That's one acceptable answer. Or you could also say x is greater than 7 divided by 4. It'll go in one time, and you have a remainder of 3 over the original 4, and it is negative. So x is greater than -1 3/4. That's also an acceptable answer. I would just say leave it as an improper fraction, though. Moving on to number 4, this is a compound inequality. And if you know how to solve a regular inequality, then you know how to solve this one. So like right here, what are the 2 steps to solve it? What would you do? Add 20. And then after you add 20 to both sides, what would you do? Divide by -4, right? And that's exactly what you're going to do. But instead of just there being this side and that side, you have whatever you do to the middle, you do to both outside sides. So you're still going to add 20 first and add 20 over here, but you got to also add 20 over here. So your new compound inequality becomes 12 is less than or equal to negative 4x is less than or equal to 68. And now you want to get rid of the minus 4 in front of the x, which is multiplication. So you're going to divide by negative 4, divide by negative 4, divide by negative 4. Okay? So what we end up with is negative 3. Now here's the tricky part, guys. Since we divided by a negative, we have to take that symbol and flip it, and it's going to become greater than or equal to. Okay? And then that cancels out. You still have x in the middle. That's the goal, to get x by itself in the middle. And also, since you divide by a negative, this one has to flip as well. So it's going to become greater than or equal to. And with the calculator, 68 divided by 4 is 17. So we end up with a negative 17 on this side. Okay, so this is almost fully correct. But whenever we have a compound inequality, you always want to write the smaller number on the left side and the bigger number on the right side, right? So what we should do right here is, we should put the smaller number, negative 17, on the left side, the bigger number, negative 3, on the right side, x in the middle, and since you put the smaller number on the left, the bigger number on the right, it has to open up to the right always. In other words, it's like taking this whole thing and flipping the whole thing. So since you move this to the front and you move this to the back, then these guys have to flip as well. You see, this is a correct answer. It's correct for sure. X is bigger than negative 17 and x is smaller than negative 3, right? So over here, it's the same deal. X is smaller than negative 3, x is bigger than negative 17. The bottom line is, put the smaller number on the left, bigger number on the right, and it always has to open up to the right because the bigger number's on the right. And this is the best answer that you could put for this question. If on an open response test, maybe I'll deduct a fraction of a point. I don't know, you know. So I want to encourage you guys to always write your compound inequalities with the smaller number on the left and the bigger number on the right. Anyway, we already did 5. What else? Write an equation in slope-intercept form of the line that passes through the following information. Okay, so this is a good one because it's Algebra 1 stuff. What do I give you? I give you a point, x1, y1, and I also indirectly give you a slope because I tell you that your line is perpendicular to this line. Now, you got to remember what parallel means and perpendicular means. Parallel means same exact slope. Perpendicular means opposite reciprocal slope. So our actual slope is going to be the opposite and the reciprocal. So negative 1 over 3. Perfect. Okay, now, where do we get that from? You see, this slope right here is right here. It's 3, technically 3 over 1. So when I say opposite reciprocal, you got to flip the fraction and change the sign. So it's going to be a negative 1/3, and that's exactly what we have over here. So indirectly, they told us that our slope is negative 1/3. Okay, so we have a point and we have a slope, and hopefully we remember point-slope form, which is y minus y1 equals m parentheses x minus x1. And since you have an x1, y1, which is a point, and since you have a slope, you might as well plug it into point-slope form. So I recommend whenever you use point-slope form, use blank spots when you're plugging in. That way you could say my y1 is negative 5, my x1 is negative 9, and my m, since it was perpendicular to the other slope, is negative 1/3. Okay, so here's our equation. I believe they might ask you to write it in slope-intercept form. So if I do ask for slope-intercept form, you got to change it and get y by itself. So first you would change the minus minus to plus plus, and then you'd have to distribute the negative 1/3 and then get rid of the 5 to have the y by itself. So, man, I'm running out of space here. So let's see. When you distribute, negative 1/3 times x is negative 1/3 x. Negative 1/3 times 9. With the calculator, that'll be a negative 3. And you still have the equals and the y plus 5. So you would have to subtract 5 and then subtract 5 And your final answer will be y equals negative 1/3 x minus 8. Okay. So if they ask for it in slope-intercept form, that would be your answer, y equals negative 1/3 x minus 8. If they ask for it in point-slope form, you could technically leave it like this, y plus 5 equals negative 1/3 x parentheses x plus 9. And number 7, they want you to write an equation that's parallel to this one. And again, parallel means same exact slope. So that slope right there is 5. So your slope is also going to be 5. Okay. And they're telling us that the y-intercept is at 7. What the heck's a y-intercept? The y-intercept is the b value in y equals mx plus b. Okay, so this is the b value. And you already know the m value. So you just plug that in right there and plug in this 7 right there, and you have your equation in slope-intercept form. Y equals 5x plus that b value of 7. And there's your equation. Too easy. Number 8. Again, number 8 is technically an Algebra 1 question. You need to know everything that there is to know about lines in Algebra 1. First thing you should know about lines in Algebra 1 is how to find the slope. And the slope formula, if you have 2 points, is y2 minus y1 over x2 minus x1. And then after you know your slope and you have some points, which you obviously have a bunch of points here, and if you label this one your first point, then you would use this point and your slope to write it in point-slope form. And last but not least, when you're writing a prediction equation as they're asking for it here, you probably are going to want to change it to y equals mx plus b. Sorry, I'm kind of running out of space here. But anyways, yeah, again, you need to know the slope formula, you need to know point slope, and you need to know slope intercept. Those are the 3 things you need to know. So what do they give you? They give you some data, they give you some information, and they're telling you use the first one and fourth one, and they're going to highlight them as well. So this is your first one, that's your fourth one. So you might as well write those down wherever you can. You might, there's probably not enough space for you to do it here, but here are my 2 coordinates. And each of those are an x value and a y value, and x value and y value. And I called this one my first point, x1, y1. I called this one my second point, x2, y2. So now I could actually use this slope formula. And when you're using the slope formula, or any of these, I always recommend rewriting them with blank spots and then plugging in your values. So I want to plug in y2, which is 409, y1, which is 133, x2, which is 42, and x1, which is 17. And I am definitely going to use a calculator. It's 409, take away 133, that is 276. So we have 276 over 42, take away 17 is 25. Okay, so if you look at the instructions, it says write it as a decimal. So we're going to write it as a decimal. On your calculator, you could type in 276 divided by 25. And if it gives it to you as a fraction, if it leaves it like this, then you could hit the SD button and that'll switch it to a decimal. SD button switches fractions to decimals. So 276 divided by 25, use the SD button, it'll be 11.04. So the slope is, the m is 11.04. Okay, that's my slope. I know it's ugly, it has decimals. But we are now going to use this slope and this point to write it in point slope form. Okay, so here we go. I'm going to rewrite the point slope form. We're running out of space here. Y minus y1 equals m parentheses x minus x1. And yes, I'm using blank spots. The m value we just said was 11.04. It's ugly. The y1 value is 133. And the x1 value is 17. So that's in point slope form. And with the calculator, you're going to distribute 11.04 times x. That'll be 11.04 with an x. 11.04 times 17, that with the calculator is 187.68. Negative 187.68. And we have the y minus 133 on the left side of the equal sign. So you got to get rid of that minus 133. So you're going to add 133. You're going to add 133. So of course, you're going to end up with y by itself. Y equals 11.04x with 133. With the calculator, that'll be a negative 54.68. And that's your prediction equation. So you get a point if you could find that prediction equation. And then after that, they want you to use this prediction equation to calculate the missing value. So if you plug in a 60, all you got to do is plug in a 60 right in there. Once again, I want to take this 60 and plug it right in here. So it'd be y equals 11.04 times that 60 minus 54.68. With the calculator, 11.04 times 60 is 662.4. So y equals 662.4 minus 54.68. With the calculator, you get 607. Y equals 607.72. So that should be your answer for the output given the input 60. So 607.72 would be the answer for the output given the input 60. All right, moving on. These are fun. It says graph on a graphing calculator. We're not going to use a graphing calculator. We know what these look like just by understanding the A value, the H value, and the K value, right? We already know that this is going to be a graph that's like a V, where your HK is negative 1, 2, right? And we already know that this one's going to be a parabola opening up that gets vertically stretched by 2 that has the vertex at positive 2, 5. We already know that this guy is also a V-like graph with the vertex at negative 2, negative 1, opening down vertically stretched by 3. So talking about the domain and range of any V or U that opens up or down, the domain's always going to be x equals all real numbers. So on number 9, the domain is x equals all real numbers. Number 10, same thing, the domain, x equals all real numbers. Number 11, same thing, the domain is x equals all real numbers, okay? What would the range be on number 9? Well, it's good to get a little visual. So if you're at your notebook, you could identify the HK of number 9. And the HK of number 9 would be negative 1, positive 2. So imagine that, negative 1, positive 2, it's going to be up here, negative 1, positive 2. And we know that this is opening down, and it's going to be a V, not a U. And when it's a V, you're going to use the pattern, not the pattern, you're going to use the slope, down 1 over 2. So from this point, you're going to go down 1 over 2 in both directions. So it's going to look like a V like that. That doesn't look like a V. Let me, hold on a second. Like that, kind of, whatever. But the reality, if I'm asking for the range, I'm just talking about where this graph exists in terms of up and down. And you already know that the highest point is at the location negative 1, 2. So it can't exist at 3, can't exist at 4. It exists at 2 and below. So how would you say that? The range would be y is at 2 and below. How do you say that in terms of an inequality? Less than or equal to 2, okay? And the range, doesn't matter if it's a V or a U, the range is always going to be involving the K value. Bless you, the K value of your vertex, okay? So on this next one, does it open up or down? It opens up because it's positive. So you know that this is your vertex Y value and it has to open up. So it's going to be what? Y is greater than or equal to that negative 5. That's the range right there. Okay. How about the range for the last one? It's going to be Y is what? Because it's negative, it's going to be less than or equal to the K value, which is negative 1. Any questions there? kind of hammered that out. Write the piecewise function of the following graph below. Okay, so a lot of students got confused when we did this the first time. A lot of students still get confused now. The idea is that you got to identify the entire line of each one of these. So there's this blue one, there's this green one, there's this red one, okay? Let's start with the blue one. In order to write a line, you need two things. You need the M and the B. And you look at it from left to right. It doesn't matter if you're like, oh, it has a dot here and it has an arrow going this way, so I need to go up one, over one. No, that's not true. This is only a piece of the entire line. So where would the entire line be at? It'd be going this way as well, right? But we know that it doesn't because we're only showing you half of the line, a piece of the line, okay? But the reality is from left to right, what is your slope? From here to here. You go down 1 over 1. So your slope is -1. So, I mean, even from up here, down 1 over 1, down 1 over 1. If you kept going with that slope, down 1 over 1, you'd end up right here at that B value. So the B value is -3, right? Down 1 over 1, it would cross right here. If you showed the whole line, it would cross at -3, but you're not showing the whole line. So what is the line itself? It's y equals down 1 over 1, x minus 3. And you don't even need the down 1 over 1. You could just put a negative in front of that x. Okay, let's go for the green one now. From left to right, am I going up or down? I'm going up. How many do I go up? I go up 2 over 1. So my slope is 2 over 1. So my green one's going to be y equals 2 over 1 x. And where does it cross the y-axis? At +1. So there's my equation. Y equals 2x plus 1. And the red one, well, we got to look at two nice points. That's not a nice point. That's not a nice point. That's not a nice point. Where are the nice points at? At the y-intercept of -1 and at this other one, which is down 2 over 3. So the red line is going to be y is equal to down 2 over 3x, and it does cross the y-axis at -1. It's down 1, 2 over 1, 2, 3, right? -2/3, and it does cross at -1. Okay, so these are your three equations. But if you want to write the piecewise function, you have to write it with conditions. And first of all, you're going to use the notation f of x equals, you're going to do some huge brackets because you got to write all three pieces. And you're going to start writing it from left to right. So you're going to start with the blue one. So y equals is represented right here. F of x is the same thing as y equals. And this is the part that you're going to write right here. And that's going to write it nicer, you're just going to put -x minus 3 instead of -1 over 1. So we're going to put -x minus 3. And it has a condition. You're going to say if what? If your x values are to the left or to the right of a certain x value, this blue piece starts existing at the x value of 1 to the left. And it is a solid dot. So you're going to say if x is to the left is less than or equal to that -1. You see, if you did graph y equals -1 over 1x minus 3, it would be the whole thing. But the condition tells us to only look at it from -1 to the left. So if x is less than or equal to -1. Moving on to the next one. The next one's the green part, and you're only going to write this part right in there because the y equals is represented with the f of x equals. So you're going to put 2x plus 1 as a middle one. I'm going to put 2x plus 1 as a middle one. If, now, where does this green one exist in terms of the x-axis? Does it exist over here at -3? No, the green one starts existing here, and it doesn't exist over here at 4. It ends it right there. So it's between what x values? -1 and 0. Between -1 and 0. So we're going to put the -1 and the 0 with the x in the middle with less than symbols. -1 smaller, 0 is bigger. Smaller number on the left, bigger number on the right. And then you have the less than symbols on both. They have to open up to the right. Anyway, this one is an open dot at -1. So I'm not going to put a solid line underneath it. But this one is a solid dot at the x value of 0. So I need to put a solid line underneath that one. Okay. And last but not least, y equals -2/3 x minus 1. So we have the y equals, we're going to put -2 thirds x minus 1. And then the condition if, where does this red piece exist in terms of x? Does it exist at -2? No. -1? No. Where does it start existing? At 0 to the right. So, and notice it's an open dot, so you're just going to put if x is greater than 0. And there's your entire piecewise function with its conditions. Okay, I hope that that makes sense. Dang, I'm sorry. Killing you guys. Solve the inequality, that's easy. Whenever you have x equals a number, that's going to be a vertical line, right? X equals a number is a vertical line. So right here, you're going to draw the vertical line at -2 on the x-axis. So here's -2 on the x-axis, vertical lines going up and down. But before I draw my line up and down, is this going to be a solid line or a dotted line? Dotted, because it does not have a solid line underneath it. So this is going to be a dotted vertical line. Okay. And also, we need a shade either, most of the time I say above or below, but that's when you have y by itself, and there is no y right here, it's x. So what does less than mean on the x? Is it to the left or to the right? It's to the left. So you would shade or highlight this part over here. Now, this is not going to be your final answer, though, because the final answer is where it overlaps, okay? So the other one, I'm going to graph in blue, but before graphing, of course, I need to get in y equals mx plus b. So I'm going to divide by 2, divide by 2, divide by 2, and I'll have y is greater than or equal to, that's a -1 over 2x plus 2. So I want to graph this guy in blue. It crosses the y-axis at 2, that's the b value, that's this guy. And then from that point, I go down 1 over 2. So down 1 over 2, I would be right here, and down 1 over 2 right there. And I could use the pattern backwards to get to here and up there, and so on and so on. So before I draw my line through those blue dots, is it going to be a solid line or a dotted line? Solid. So I'm just going to go solid line going right through those blue dots as best I can. And now, with respect to this blue line, am I going to be shading above or below? What does that say? Y is what? Y is greater than. Is greater than above or below on the Y? It's above. So I need to shade above this blue line. Okay? So I need to shade everything up here above the blue line. Now, the thing is this. A system, the solution to a system is the points that they share. So if we know that the highlighted area are the points that are solutions, where are those points that they share? At the overlap piece. So the only actual answer is this little triangle piece right here. Triangle piece right here. That's the only thing right there. Okay. Let me do it with really coloring it in. Okay. Now there is an infinite amount of answers, but the way it's going to appear if it were a multiple choice test, but it's not. But you should draw it where you could clearly see that this side is solid and this side over here is dotted. Okay. So it's that little triangular piece, the overlap. And down to the last one here. Solve the following system. I said, dang, this is a long one. This is a messed up one. Final question on this worksheet. Let's begin by looking at the equations. Is there anything that you guys would like to cancel? X's, Y's, or Z's? Z's look easy because of these guys, right? So that's exactly what we're going to do. We're going to use the second and the last one to get the Z's to cancel. And we're not going to do anything. We're just going to rewrite them. And when we combine them, the Z's cancel. And we end up with a negative 13x plus 11y, the equal sign. And what is that? Negative 61. Okay, and this guy is what we call new equation number 1. And now we need to go back and use the one we have not used. So we haven't used that top one. So I'm going to rewrite it down here. And we need to combine this top one that I just rewrote with any of the others to get the same variable to cancel. So if I cancel z's over here, I need to cancel this negative 5z. Now, I've seen, oh, what the heck? My bad. Sorry about that. So anyway, I've seen this I've seen students get confused because they're like, well, negative 5z, how am I going to change that to a positive 5? How am I going to change that to a positive 5? I can't do it. But just pick one. Do you want to use the middle one or the bottom one with this one? Pick one. Middle. Okay, so I want to rewrite the middle one just right below it. Here it is, negative 3x plus 5y plus 2z equals negative 27. Okay, now we still need the z's. Why do I keep doing that? Sorry, I accidentally erased it. So we still need the z's to cancel out. And the only way that's going to happen is if you modify both of them to change this to a negative 10z and this one to a positive 10z. So you're going to multiply the top one by 2 and the bottom one by 5. So the top one, you're going to have 4x plus 8y minus 10z equals 36. And the bottom one is going to become negative 15x plus 25y plus 10z equals 135, negative 135. Right? Okay. Use the calculator. Anyway, now we could actually combine the lines. Why did I use a highlighter? My bad. So yeah, when you combine 4 with negative 15, that's a negative 11x. When you combine 8 and 25, that is a 33. That canceled out, and 36 take away 135 is negative 99. Thank you so much. My brain's not working right now at this point. So this is our new equation number 2 right here. New equation number 2. So we're going to take new equation 1 and new equation 2 and create a 2x2 system that we're going to solve. So obviously there's no space to do it on this worksheet, but I am going to just rewrite it right here. My new 2x2. And that'll be the negative 13x plus 11y equals negative 61. It's going to be the negative 11x plus 33y equals negative 99. And I need to solve this guy, so I either choose to cancel out x's or y's. If I choose to cancel out x's, I'm going to have to modify both of them. But if I choose to cancel out y's, I only have to multiply the top one by a negative 3. So obviously the easier path is to cancel out y's by multiplying the top one by negative 3. So when you multiply by a negative 3, that'll be a positive 39 with an x. That'll be a negative 33 with the y. And that's positive 183, correct? Use a calculator, negative 3 times negative 61, positive 183. Yep. And the bottom one, we're just going to rewrite it. That's negative 11x plus 33y equals negative 99. Now we could combine and eliminate those y's, and we will get 28x equaling, I'm going to go to a calculator now. I don't even want to think about it. It's what?
84.
84. Thank you so much. So we really have 28 times x equals 84. So get rid of that multiplication of 28 by dividing by 28. And we have x equals 3. Thank goodness. So we have the x value of our 2x2. Remember, we're solving the 2x2 right now. So we're going to plug in that x value into either the top one or the bottom one, whichever one you want. I'm just going to go for the bottom one. You can pick the other one if you want. So it's negative 11 times x plus 33y equals negative 99. So plug in that 3 right there. So you're going to end up with a negative 33 plus 33y equals negative 99. So you're going to add 33, add 33. You're going to end up with a 33y equals negative 66. Then you're going to divide by 33, divide by 33, and you will get y equals negative 2. Okay, so we have x being 3, y being negative 2. We still need our z's. Okay, we still need our z's. So let's take that x and that y, and plug it into any original one. Bless you. Do you guys want to do the top, middle, or bottom? Top sounds good. So I'm going to rewrite this top one, 2x. Here it is, 2x plus 4y minus 5z equals 18. Okay, and we are plugging in the x value of 3 and the y value of negative 2. So we now get to focus in on this equation and solve it. So 2 times 3 is 6. 4 times negative 2 is negative 8. Bring down the minus 5z. Bring down the equals 18. And of course, 6 minus 8 is negative 2. So we really have a negative 2 minus 5z equaling 18. And I get rid of the minus 2 by adding 2. Adding 2, we'll have a negative 5z equaling 20. And you divide by negative 5, divide by negative 5. Z equals negative 4. So we have our x, we have our y, and we have our z. Give me a second. I'm going to zoom out and show you. So the ordered triple to this last question is parenthesis x first, that'd be a 3, y second, negative 2, and z, negative 4 being third. That's the ordered triple. Now, of course, you could, with the calculator, type in the x, the y, and the z right here, there, and there in parentheses with the calculator. Do all this side, hit equal, and it should give you 18. Same thing here, hit equal, it should give you negative 27. All you got to do is type it in with parentheses, right, to double check your answer. So, yeah, we're done.